Alright, for this question paper, what I'll try to do is go over this question paper as a whole, meaning I'm going to be answering all of the questions in this question paper. From question, I believe it's question 1 all the way up to question 5. Let's just double check. Yeah? Yes, all the way up to question 5, which the last question is what is this? Linear programming, right? So we're going to go over this question paper. It's the first paper, NQL level 4. It's a question paper abayibhala back in 2018 February. So this was a supplementary exam. Okay, so whenever you go over your question paper, please make it a point. Oh, you know what? Make sure you go over our instructions. Go over your instructions. Always read your instructions. It's gonna tell you how to do the rounding off, right? How to do the rounding off. How the question paper is structured. All of that stuff. You'll find some important information over the instructions page. Okay, it's 3 hours. Mark allocation is 100. Okay, it's 100. So this is question 1. Now another thing during this recording, I'll be slicing up this question paper to each of the individual questions. So question 1 will have a video on its own as well. So I'm gonna upload the full question paper and upload each of the individual questions of this question paper. So if you are watching question 1, in the description box there's gonna be a link for the entire question paper if you are interested in watching the whole recording. Okay, enjoy the record. Enjoy content, leave a like on a question, or you want to engage on something, a mistake that I made on the recording, or maybe you want to add something to the conversation or a different alternative. You can talk in the description box of this recording. Okay, so this is question 1, and thanks for tuning in. Let's get into it. Now, question 1.1. Various options are provided as possible answers to the following question. So choose the answer and write only the letter next to the question. So it's a multiple choice question basically. Now, question 1. For this question 1, we have, in fact, question 1 is a question on complex numbers. Okay, so question on complex numbers. So the first question, 1.1.1, there's a complex number z, -3 minus 4i, where I is equals to square root of -1 in polar form. So basically we have to change this z into a polar form. So we're gonna do the whole step where we change from standard to polar form and look for the correct answer over there. Okay, this is A, this is B. Okay, this is A, this is B. So we're gonna go through the Argand diagram route. We're gonna sketch the Argand diagram, get the argument, get the modulus as well. Then we're gonna compare the answer we got with the options that are given, or you can just use the calculator if you know how. Okay, there's also a recording for that. I'll leave it in the description box as well. I've done a recording where I teach you how to convert complex numbers. Okay, so let's calculate our modulus. So R is equals to square root of A squared plus B squared equals to, what is R? What am I doing? Okay, so it's gonna be the square root of, what is A? It's -3 squared plus, what is B? -4 squared equals to, we're gonna say -3 plus -4, don't forget to square, it's square. I'm getting a 5. So R is 5. Okay, A, B, C, D, they all have 5s on the side. So we are going somewhere. We are headed somewhere. Now, the next step would be to draw a Argand diagram. Well, if you are in an exam, I prefer you do the calculator method, especially for the multiple choice questions. It's going to save you time, but for the sake of this recording, I'm just going to use the Argand diagram for this discussion. So A is negative, B is negative. So where is that? It's in the third quadrant. It's in the third quadrant where we find A that is negative, and at the same time B is also negative. So we have -3 and we have -4. This is the B axis and then this is the A axis. Okay, then this is the argument. The arguments, we're going to calculate it by saying 180 plus theta, because the complex number lands in the third quadrant. Okay, so let's calculate the acute angle. So we're gonna say theta. This is not the real let me just say theta ref. It's the reference angle, the angle we're gonna add to 180. That's what I'm calculating right now. So it's the theta ref, where we say the tan of B over A. Then it's tan, what is B? B is gonna be 4 over A, which is 3. Remember, when we substitute the positive values, not the negative values. So I'm taking this, a substituter, 4 over 3. Wait. I'm getting a 53, 130 degrees. Therefore, the argument, not the reference argument, but the argument, the actual argument, this argument is now going to be equals to 180 plus 53, 130 plus 180. I'm getting 223. 233, 130. Okay, so this is out of the picture. So the answer is going to be this one, because R is 5 argument. We got the same 5 even here. And then the argument, it's 233, 180. And then same with this one. Okay, same with this one. So an important thing to remember is that each quadrant, there's a reduction formula that we use, right? Here we have 360 minus, here it's 180 minus, and then in the third quadrant it's 180 plus. In the first quadrant, there is no formula that we use to calculate. So if your complex number is in the first quadrant like this, there's no need to add 180 or subtract 180 or subtract 300 from 360. You're just going to take the reference angle as it is, if the complex number was in the first quadrant. So the answer, it's going to be B for this one. It's going to be B. Now let's jump to 1.1.2. The factors of x squared plus 25 are, all right, I'm gonna write something on the side like this. It's simply the opposite of what we have here. The x squared minus 25, this is a difference of two squares. We can factor out, we can find factors for this. It's gonna be x minus 5, no, x plus 5. This is what we call a difference of two squares. But an x squared plus 25, no. This is not a difference of two squares, but it's something that we can solve using what? Complex numbers. Yeah? Using complex numbers. So we're going to say x, another x, another x. We simply solve it as, we treat it like a difference of two squares, but we're going to have to use complex numbers in the process, right? Because this thing, in the normal number system, in the real number system, this thing cannot be factorized. But since we have complex numbers, now we'll be able to find factors using complex numbers. So we're gonna say plus minus, just like we did on the difference of two squares. Then I'm gonna say 5i and another 5i like this. When we do the foiling process again, it's gonna take us back to x squared plus 25. So the answer should be not this one, not this one. It's not a difference of two squares, but B is the answer. B is the answer. Let me show consistent. So B. Whoa, okay, there's a typo. There's a typo. It should be D, not B. Not B. Should be D. There was a typo there. All right, so the answer should be D, not A as well. Why? Because x minus 5i, x minus 5i as well. So this doesn't make sense. Or you can test out or look for the correct answer by taking each of these brackets and multiplying them out and see if you get the x squared plus 25, right? But that's going to take you a while to get to the correct answer. So those are the factors for x squared plus 25. Third one, simplify. So we're going to have to simplify this expression and see which answer is the correct one on the given option. So this is 4i plus i6 minus negative 3 plus 0i equals to minus 4i plus properties of I. We're going to apply that. So we're going to say I squared and then 3 outside. Then we're going to have a plus 3. 0i is just going to be 0, right? So the 0 disappears like that. Equals to minus 4i plus I squared, that's minus 1, plus 3. A complex, a minus 1 raised to an uneven number like 3. You can punch this on the calculator. You should get a minus 1 plus 3. We add the like terms. We get what? We get a plus 2. Who's the correct answer there? Nope. Definitely not. So between B and C, someone is correct. The 4i is negative, so the correct answer should be B. Should be B. The answer is B. Then for the 1.14, all right, let me just generate some space, create some space on the side. Then we're gonna have a 1.1.4. Simplify. Okay, we foil. Let me check. Okay, let's just save up some space, maybe for the last question. We're gonna write to 1.1.5 right here. So the 1.1.4, just to save space, my writing space, I'm gonna solve this one right here. So this times this gives us a 4, and then this times that gives us a minus 2 minus square root 25, and then this multiplies that, you're gonna get a plus square root of minus 25. A minus square root 25, square root minus 25 times a minus square root 25, we are getting a minus, because a negative times that, a positive times that negative gives us a negative. The square root of negative 25 times the square root of negative 25 is giving us a negative 25. Sat laws. Square root a times square root a is equals to a. That's what I applied. So 4, this cancels out this one. Same, these are like terms, the only difference is it's the signs. The negative times that negative, it's a plus, so it's plus 25 equals to 4, that is 29. So the correct answer should be A. The correct answer should be A. Let's change the marker. So A is the correct one. Now for the next one, 1.1.5. So for x and y, if 3x minus 4i is equals to minus 6 minus 16i. Now, 1.1.5 is a simultaneous equation. 1.5 it's a simultaneous equation. So whatever I'm going to be showing here, we're going to apply it on 1.5. Look, when simplifying a simultaneous equation, you need to simplify your equation on the left hand side as well as the right hand side. If there are brackets, remove them. If there are roots, remove them, right? Something like that. Just simplify it in such a way that you end up with a left hand side that looks like this: real part plus imaginary part. And on the right hand side as well, simplify to a point where you get a, or end up with a real part plus an imaginary part. Then you're going to equate the real parts and equate the imaginary parts. So for this case, no need for us to simplify, because the left hand side is in standard form, meaning that we have the real as well as the imaginary part. On the right hand side, I have the real and the imaginary part. We're just going to equate the real and the imaginary part. So a, it's the 3a, it's the 3x on the left hand side. We equate it with c on the right hand side, which is negative 6. Divide by 3, divide by 3. Cancel, cancel, x is equals to minus 2. We have the x value. Now to get the y value, we're going to equate the imaginary parts now. The imaginary part, it's the negative. Remember to take the sign as well. It's minus 4yi equals to the negative 16i. Okay, I want to solve for y. I'm solving for y. So I'm going to divide both sides by minus 4i, minus 4i. Cancel, 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 cancel. I'm left with y. I cancel, 16 over 4. That's going to be 4. Now we can check our solutions. Alright, I don't think there was a need for us to solve the y, because if you take a look at the solutions that are, or the options that are provided, there's only one option where x is equals to negative 2. So it would have been obvious from the beginning. So B is the solution for this one. Okay. Yeah. Okay, that concludes the multiple choice questions. Now let's jump to some real stuff here now. The real stuff. Let's just divide the paper like this, just to save some residence for writing. Okay, so we have 1.2. Let's write it from this point. 1.2. Let's simplify and leave the answer in rectangular form. So 1 minus I over 2 plus 3i. This wants us to use a, or multiply that fraction by its conjugate like this. 2 minus 3i equals 2, and then this multiplies that, gives us what? 2 times 1, that's 2. The 1 multiplies that negative 3i, we get a negative 3i. This multiplies that, gives us a minus 2i. The negative I and that negative 3i gives us a plus 3i squared. Then we divide everything by the product of the denominator. So the 2 times 2, that's 4. The 2 multiplies that negative 3i, gives us a 6i. This and this gives us a plus 6i. 6i, and then the 3i and that 3i gives us a negative 9i squared equals 2. So it's 2, doesn't have a like term. This one and this one gives us a minus 5i and a negative 3, because I squared is negative 1. Negative 1 times that 3 gives us a negative 3. Divide. and then this cancel. We're gonna get a 4 plus 9 equals 2. This and this gives us what? Minus 1 minus 5i over 4 plus 9. Come on, 4 plus 9, 13. We get 13 equals 2. That's going to be minus 1 over 13 minus 5 over 13i. So this would be the answer for simplifying that to a rectangular form. So a rectangular form simply means that leave your answer as a plus bi. A plus bi. That's a rectangular form, or another word would be standard form. Yeah, so then 1.3, add these two and leave your answer in rectangular form as a plus bi. So we're gonna say for 1.3, we're gonna say 1.3. Now the keyword, it's add. Take z1 and z2, add the two and leave your answer in rectangular form at the end. So we take z1, we add it to z2. Square root 3 cis 60 plus 2 square root cis of 45 degrees equals to, okay, guess what? Z1 is in polar form. Z2 as well is in polar form. And polar forms cannot be added. So we need to change these into standard. So square root 3, we open a bracket, then we say cos 60 plus I multiplied by sine 60. That is how we change polar to standard. Then it's going to be 2 cos 45 plus I times sine 45. And then we punch this on the calculator. Don't waste time, man. Don't waste time. What is cos 60? That is a half. Square root 3, 1 over 2 plus cis 60. That is square root 3. Oh, okay, square root 3 over 2. I plus, and then cos 45. Cos 45, yeah, you can punch this, man. You can punch this. And then you're gonna get a square root 2 over 2 plus cis 45. It's square root 2 over 2i equals to, we multiply, we get a square root 3 over 2. This times that gives us a 3 over 2i. This multiplies that, gives us a square root 2 plus square root 2i. Alright. Okay, so leave your answer in rectangular form. Okay, at this point I don't think we have a choice but to add the real with the real and the imaginary with the imaginary. Then our answers, let's round them off to 3 decimal places, because adding a square root 3 over 2 and a square root 2, it's gonna give us a very funny answer. So just change the answer to 3 decimal places. So we're gonna say we add this with this, these are real, and this one with this one. So adding the purple should give us a 2,280 plus 2 over 3 plus square root 2. 3 over 2 plus square root 2. This gives us a 2,914i. This is the final answer. Okay. And then for 1.4, okay, I'm gonna erase the whole thing. Let's just write it here. Then it's gonna be 1.4. 1.4. Apply De Moivre's theorem to calculate the following. Leave the answer in polar form. Nice, nice, nice. Okay. Leave answer in polar form. Ungabi easy la. Yeah, ungayilahli network man. We share in polar form. You solve, leave the answer in polar form. Okay? So let's apply De Moivre's theorem. So it's gonna be equals to, De Moivre's theorem says take the modulus, which is square root 9, raise it to exponent 4. Take the same exponent and multiply the argument with it. Multiply it by 4. Then you multiply the argument with it. Alright? And then we're gonna say 2 raised to exponent 5, and then it's gonna be this 330, multiply that by 5 equals 2. So square root 9, close bracket, raised to exponent 4, we get a 81. We get 81. And then 230 times 4, 920. 920. And then for that 2 raised to exponent 5, 32. And then for the other one, it's 330 times 5, that's 1650. 1650 equals to, then we're gonna say 81 over 32. 81 over 32, that gives us what? 2,531. And then we subtract the arguments. 920 minus 1650, I'm getting a negative 730. Yeah, 730 is equals to 2,531. This, okay, so we shouldn't leave our answers in polar form. We shouldn't leave our arguments with negative values, right? So we're gonna add a 360 to that negative 720 plus 360. I'm getting negative 370. We add a 360 again, then I'm getting a negative 10. Add a 360 again until you get a positive value. I'm getting a 350 degrees. So this is the final answer for this 1.4. Now let's do the last one. That's a simultaneous equation. What's going to happen now is that I'm just going to erase everything so that we can have space for solving this one. Yeah, it's going to take quite a while to crack this one. So let's just erase. Okay, it's a simultaneous. Okay. Everything else goes as well as this part. Okay. So let's do 1.5. 1.5. So for x and y, if 1 minus I equals to 2x plus yi plus I5, 11i5 minus 13 plus 3 y plus xi. Like I said, you need to simplify. You need to make sure that you simplify before you can equate the real and the imaginary part. A plus bi is equals to c plus di. Real equals real, imaginary equals imaginary. You see, this statement doesn't have a bracket. It doesn't have a bracket, so we need to remove the brackets, combine like terms if there are any, and then you equate the real with the the real with the real, imaginary with the imaginary. On the left hand side, we just leave it like that. To remove the first bracket, that's going to be a 2x plus 2yi plus this I multiplies that, gives us a 11 I raised to exponent 10. It's 5 plus 5, that's 10, minus 13i5 plus 3y plus 3xi. I don't think there are any like terms. There are no like terms. However, we can simplify the right hand side further because we have I values that are raised to higher exponents. This and this, you can see that the i's are not raised to any values, right? On the statement, on the initial statement that I declared, there are no I squared or I5 or I10, nothing like that. You should simplify I values with powers that are bigger than 1. né? So we're gonna have a 1 minus I equals to 2x plus 2y. These don't have any like terms. Then this is gonna be a plus 11 I squared raised to exponent 5 minus 13 I squared, okay, not 4, but 2 multiplied by I. 2 times 2, that's 4, multiplied by that I takes us back to 5, plus 3y plus 3xi. 1 minus I is equals to 2x plus 2yi. Okay, then 11 I squared. Okay, let's take it step by step. 5 minus 13 minus 1 squared. Then we have this I plus 3 plus 3xi. Yeah, plus 3xi. Then we're going to have a 1 minus I equals to 2x plus 2yi. Negative I raised to exponent 5, that's going to be negative 1. This negative 1 times the 11, we're going to have a negative 11 like this. Negative 1 raised to exponent 2, that gives us what? Oh yeah, that gives us what? A positive 1. Then this is going to be minus 13. Don't forget this I, we put it here. Plus 3y plus 3xi. Okay, 3xi. I don't think there are any like terms as well, but we'll have to group the real parts as well as the imaginary parts. Let me show you what I mean. The right hand side, because there's a lot going on this side. So let me just paint all the real. This is real. This is real. This is also real. How do I know? All of the values that I painted in purple, they don't have any I value. They don't have the I. So the green are the ones that are considered to be imaginary. So the purple, let's move them one side. Plus 3y is equals to, okay, not equals to, but plus 2yi minus 13i plus 3xi. Okay, plus 3xi. So the imaginary, the real, I'm going to equate it to the real on the other side. So it's going to be 1 equals to 2x minus 11 plus 3y. This is the imaginary, the real part. And then for the imaginary part, it's going to be minus I equals to 2yi minus 13i plus 3xi. Okay, 3xi. So we can maybe rearrange this formula or simplify it further. Do we have to though? I don't know. But let's just fix this. Let's cancel out the i's, because on the right hand side I is a common factor. Let's take it out. Minus I 2y minus 13 plus 3x. Divide by I, not minus I but by I, and then we divide by I. They cancel. We're gonna have a minus 1 equals to 2y minus 13 plus 3x, like this, equals to 3x. Is there a simpler way of solving this one? I don't think so. Okay, so I think let's bring over this 11 to the left hand side. Now what is left is to solve for the x and y simultaneously. We're gonna have a 11 positive 11 plus 1, 2x plus 3y. We add, we get what? We get 12 equals to 2x plus 3y. And then we can simplify this by bringing this over this side. We're gonna have a minus 1 plus 13 2y plus 3x, and then we do what? We add, we get 12 2y plus 3x. This is equation 1, this is equation 2. Now we're gonna have to solve this simultaneously. Now whether you use the substitution method or the elimination method, it's really up to you from this point on. But I'm thinking of using a multiply by 2. You know what, let's use a substitution. Let's use substitution. X, yeah, perfect. Let's use the substitution. So I'm gonna take the second equation and generate the third equation and substitute it over equation number 1. I'm gonna make x the subject. Even if you make y, it's also fine. Minus 3y equals to 2x. Divide by 2. Divide by 2. Cancel. Gonna have a 12 minus 3y over 2 is equals to x. Now this is equation number 3. Sub 3 into 1. Sub the 3 into 1. So we're gonna say 12 is equals to 2y plus 3. 12 minus 3y over 2. Ish, what a boring equation. Okay, it's fine. 2, and then we're gonna have to multiply. Let me just write the line with this. Then we'll have to say 12 is equals to 2y plus the 3 times 12 gives me 36 minus 9y over 2. Over 2, then I'm going to multiply by 2 throughout so that I remove the fraction. The 2 is the LCM. Multiplied by 2. I'm going to get a 24 equals to 4y plus 36 minus 9y. And then let's bring over 36 this side. It's going to be 24 plus 36 is equals to 4 minus 9, that's 5, negative 5. Y. No, wait. I think I made a mistake. It's supposed to be negative 36. It's supposed to be negative 36, not 24 plus 36, so that's gonna be 24 minus 36 is equals to negative 12 equals to minus 5y divided by 5 on both sides. We're gonna have a 12 over 5 as the final answer. So y is equals to 12 over 5. And then we take the y, substitute it back into the original equation. So that's going to be 12 minus 3, 12 over 5, 12 over 5 divided by 2 is equals to x. And then we simplify. That's 12 minus 3, 12 over 5 divided by 2, and then the final answer becomes 12 over 5 as well. Interesting. 12 over 5 equals to x. Okay, so we have both the x value and the y value being the same, so that is equals to that. Okay, so I'm gonna erase and do question 2. Alright, let's do the question 2. So on the same page, we're gonna do question 2. Alright, so this is question 2. There we go. Okay, so question 2, we have 2.1. In fact, let me check. Question 2 as a whole, I think it's all about differentiation. Then for 2.3, it's kinematics, where we do something that has to do with motion, application of differentiation. Okay, so 2.1, use differentiation rules to determine the derivatives of the following. Leave your answer in simplified form. Let me use maybe purple. Yeah, leave your answer in simplified form with positive exponents and insert form when necessary. You guys don't read instructions. Oh, okay. Read instructions. Okay, make it a point you read instructions. Okay, read instructions. Read your instructions. I'm gonna emphasize that. Read your instructions. 2.1.1. We are given f of x. That is 5x cubed minus the square root of 4x plus 2 over 5x cubed minus 4e minus 2x plus 1 plus, okay, that's negative, right? That's negative sine 30 degrees. Okay, so first of all, you should note something, that you actually cannot take the derivative as of yet. Why? We have a square root. We need to get rid of that. We see x as forming part of the denominator, so we cannot take the derivative as of yet because of those two things that are present or part of the expression. Let's sort out this and this first. Okay, so I'm not differentiating but simplifying that expression so that we can differentiate every single term. 5x cubed plus, now 4 is a perfect square, so taking the square root of 4x, we're gonna get what? We're gonna get 2 square root x. We start off by taking the square root of 4. It gives us what? 2. The x doesn't have a square root. Okay, so it's gonna be the square root of x. Look, we are applying the third law, which says you can actually do this to your square root, not plus, but it's multiplied by square root b. You can split that apart. So after splitting the 4 and the x, it's gonna be like this: square root 4 times square root x equals to square root 4, that's 2. Then we have a square root of x like that, plus 2 over 5, and then the x on the side with the negative exponent, minus 4e minus 2x plus 1 minus sine 30 degrees. I'm not taking a derivative yet, I'm simplifying it first. Then we take this a step further. Let's fix that square root quickly. 3 plus 2x and a half. We cannot differentiate while there's a square root. X minus 3 minus 4e minus 2x plus 1 minus sine 30 degrees. Okay, now there's no square root, there's no x as part of the denominator. Now it's time to do what? It's time to differentiate. We're gonna say f prime of x is equals to this is 3. 3 times that 5 gives us what? 15x squared. We take away 1 from the 3. 2 times a half, that gives us 1x, and then half subtract 1 gives us what? Negative half. The negative 3 multiplies the positive 2 over 3, that's giving us a negative 6 over 5. X minus 4, we subtract 1 from the negative 3. Right. Okay. Alright. Okay, so there's going to be a little bit of chain rule here. So we are differentiating e. So this is going to be a minus 4 e minus 2x plus 1. Finding a derivative of e gives us e. E doesn't change. Then multiplied by this, the derivative of the exponent of e. We are applying chain rule for this one. Derivative of minus 2x plus 1 is negative 2. Derivative of sine 30 degrees, it's gonna be 0. That's a constant. That is a constant. It's gonna be 0. F prime of x equals to 15x squared plus, we now have our derivative. We have our derivative, so this is gonna be 1 over x raised to exponent half minus 6 over 5 x raised to exponent positive 4. I'm following these instructions. I'm simplified form, positive exponents, and sad form when necessary. Then this negative 2 times that negative 4, that's a plus 8 e minus 2x plus 1 and a 0. And then let's simplify this thing a bit further, a little bit further. This is gonna be equals to 15x squared plus, and then that's gonna be 1 over in sad form minus 6 over 5x exponent 4. I feel like we can do a bit of simplifying here. That's how I feel. We can do a little bit of simplifying. For this one, I also feel like you can leave it like that. But you can do the following. Remember, they want us to leave the answer in with positive exponents. This exponent is negative, right? So we're gonna say 8 over e raised to exponent 2x minus 1. The e, we take out the negative as a factor. We're gonna have a positive x minus 1 like this. Positive exponent. I'm taking out the negative outside as a factor. Then I'm gonna have a 2x minus 1. This negative exponent, that negative says e is negative. E has a negative exponent. So what's next to do is just to bring e down as a denominator. Then the 2x is now a positive exponent. Okay? Or you can leave it like that, man. Something is not make sure with that one. But just to be on the safe side, we can just do this, just to make that 2x to be a positive, okay, to be a positive. So yeah, it's debatable as to what to do from there onward, but yeah. 2.1.2, we have y that is equals to sine x over ex. Okay, that's where the principles are coming in again now. The differentiation principles, that's where they are coming in. All right, don't forget, keep these in mind. We are differentiating using some principles at some point in other instances. So let me just circle this around. Okay, let's take it back. Okay, right. Okay. All right, let's use black, man. Yeah, why not? All right, so these are the principles. This is the product rule. This is the quotient. And then this is the chain rule. This is the chain rule. So for 2.1.2, you can either use the quotient, which I'm not gonna do. I'm gonna apply the chain rule in a different way. Yeah, wait, no, the product rule. I'm gonna turn this into a product rule. However, it's obvious that you have sine as being the numerator, e being the denominator. We can just go straight to applying this rule. No, this one. I have f as being sine. I have g as being the e, right? You can apply the quotient, but for this case, well, let me say I'm gonna show you an alternative or a different way of going about solving this. So we're gonna say y is equals to sine e multiplied by e raised to exponent minus x, like this. Now I have f of x multiplied by g of x. That is why I'm saying I'm turning this into a product rule. There we go. I have f that's f. I have g, that is g. Then we're gonna apply. Then we're gonna say dy dx is equals to f. We start off by writing f, which is that sine x multiplied by e negative x plus, okay. So it's f, that's f. And then g prime, so we need to differentiate this one. It's gonna be e minus x multiplied by negative 1. Where's the negative 1 coming from? It's the derivative of x, of negative x. Then we're gonna say plus, then we differentiate f, derivative of f. So derivative of f, which is sine, derivative of sine is gonna be cos x multiplied by g minus x, like this, equals to, we multiply this throughout, we get a minus sine x multiplied by e minus x plus a cos x multiplied by e negative x equals to, then we get a minus sine x divided by ex plus we're gonna get a cos x over e minus x. No, not negative x, but positive x. Denominators are the same, we're just gonna combine the numerators. Cos x divided by e raised to exponent x. This is the final answer. Now I'm thinking how the multiplication, I mean how the quotient rule is gonna go about. You should get the same answer. You should get the same answer. The 2.1.2, use the alternative method, the quotient rule, to simplify and check if you do get the same answer or not. Alright, I'm taking this down so that we can do 2.1.3 and the rest of the question. Okay. 2.1.3, we have y that is equals to 1 over 3x squared minus 5 raised to exponent 5. Okay, I don't know how you want to play this one out, but just give it some thought. Give it some thought. Give it a bit of thought. Now, I think you can use the quotient rule. Without a doubt, you can. Yeah, definitely you can. You can use the quotient rule. However, the easiest way is to actually apply the product rule. How? By applying the same methodology that we applied with 2.1.2. So we're gonna simplify this to this. 1 times 3x squared minus 5 raised to exponent negative 5. Whatever comes from the denominator, you change the exponent to be a negative. Okay, so 1 multiplied by anything, it's that thing. So this, we can just leave it as 3x squared minus 5 raised to exponent minus 5, like this. 1 times that, it's that. Okay, then we're going to apply the chain rule. We start off by differentiating this whole thing. We differentiate what? We're going to start off by differentiating f, so it's going to be f prime. We differentiate the whole thing. After differentiating the whole thing, we take whatever is inside, we differentiate and multiply the two answers that we got. So we multiply the whole thing. So dy over dx is equals to, it's going to be the negative 5 times 1. It's negative 5. 3x squared minus 5. Then minus 5 minus 1, it's going to be negative 6 multiplied by the g inside the function. It's the 3x squared minus 5. 3x squared minus the derivative of 3x squared minus 5, it's going to be 6x. And then we multiply this with that. It's going to be the 5 times the 6. I think it's negative 35, 30. So it's negative 30x. In brackets, it's going to be 3x squared minus 5 minus 6 equals to negative 30x, everything divided by 3x squared minus 5 raised to exponent positive 6. Exponent positive 6. Oh, guess what? We're done. We're done. Done. Okay. Also, the quotient rule, it was gonna apply. It was still gonna produce the same answer. 2.1.4 ft is equals to t 3 over t squared minus 5t. I think the best way to go about this one is actually multiplying by the t inside. Don't do the product rule for this. Just multiply by the t inside. It's actually a product rule because I see f, I also see g. This multiplies that. Okay, it's a product rule. You can actually apply the quotient and the product rule, but the better option would be to simplify this by multiplying by the t. So the t multiplies that. We have a 3t over t squared minus 5t squared. That's ft. However, this t and that t, we're gonna do the following. We're gonna say ft, it's 3t exponent 1 minus 2. Dividing powers of the same base, you subtract the exponents. So it's going to be minus 5t squared equals to 3t minus 1 minus 5t squared. That's f of t. Let's differentiate. We get a minus 3t minus 2 minus 10t exponent 1, because 2 minus 1 is just going to be that 1. And then this it's going to simplify to a minus 3 over t squared minus 10t. This is the final answer. It's t, not x. Okay, so derivatives carry a lot of marks, quite a lot of marks. So just, drill yourself, do more practice around differentiation. Alright, then we get to the second part of the question, the 2.2. There's an equation of to a curve, equation of a tangent to a curve. Then we have that last part, 2.3. So let's do 2.3, but first I need to get rid of this part. Okay, so 2.2, 2.2.1, 2.2.1, determine f prime of x from first principle. So f of x is equals to 4 over x. So this is the first principle. F prime of x is equals to the limit of h approaching 0, f of x plus h minus f of x, everything divided by h. Okay, I do have f of x, it's given to me. F of x is 4 over x. F of x plus h, I need to work that out. So f of x is equals to 4 over x. The f of x plus h, we simply take f and then substitute x plus h where there's x. So I'm going to replace the x by x plus h. So f of x plus h is just going to be a 4 over x plus h. That's it. Then we take this 4 over x plus h, we substitute it into that part of the equation. So this is going to be f prime x is equals to the limit of h approaching 0, 4 over x plus h, minus, we do have f of x, you still remember, right? This, everything divided by h. Now the denominators are not the same. I have x plus h, I have x. Okay, we can either work it out in, okay, there's two ways of working this out. You can either find the LCM of the two fractions, then multiply each term by the LCM, divide the result by the LCM. Okay, but I'm gonna be using something different here, something quite different. If we students you know what we're gonna be doing now. Butterfly method, né? Butterfly method. X multiplies 4. By the way, this actually applies to any problem that involves fractions. So the 4 is going to multiply the x, we're going to have a 4x. This x plus h, it's going to multiply that 4. So we're going to have a minus 4 multiplies the x plus h divided by Then you take the denominators, you multiply them. You're gonna get an x plus h. Everything divided by h. We simplify further. Limit h approaches 0. Let's simplify that numerator part. So we're gonna have a 4x minus 4x. Okay, negative. That's gonna be a negative 4h. A negative 4h divided by x plus h divided by h equals to the limit of h approaches 0. So this cancels out that. We're gonna be left with a minus 4h over x plus h divided by h. Then we're gonna do a tip and times just to work out that fraction. Okay, so limit h approaches 0 minus 4h over x plus h multiplied by, it's h over 1, so it's going to be 1 over h like this. Okay, therefore this, it's going to cancel out that one. Okay, equals to limit h approaches 0, so it's going to be a minus 4 over x plus h equals to. Okay, so right after the h variables cancel each other out, we now have to substitute h into the equation like this. Where there's h, I'm going to substitute 0, and then the final answer is going to be a minus 4 over x squared. Ta-da! Okay. Okay, so this is f prime x equals to minus 4 over x squared. 2.2.2. Hence, determine the gradient of f of x at x equals to 2. Okay, so a first derivative represents a gradient already. All right, at any given point along the curve. So for the 2.2.2, we're just going to substitute the 2 on that derivative. So it's going to be 2. So we want the gradient at x equals to 2. At x equals to 2. So this is going to be f prime x equals to minus 4 over x is equals to 2. So where there's x, I'm substituting the 2. The final answer is just going to be a minus 1. Okay. And then finding the equation of the tangent to the curve at f of x, where x is equals to 2. So when you calculate, or when you find or calculate the equation of a tangent is a straight line. So a straight line equation is calculated by making use of a point as well as a gradient. So you need a gradient as well as a point. A gradient we do have at that given point. So gradient is minus 1. Now we need a point at that very same point of tangent between the curve as well as the tangent. Now x is 2. Y we don't know. We're going to calculate y. So y we're going to calculate like this. We take the x that is given to us and substituting it into the original equation. So y is going to be 4 over x equals to 4 over 2 equals to 2. So y is going to be what? 2. Right? Then you either use the mx plus c or the y minus y1 equals to mx minus x1. Okay, so we're going to use this one. Or you can use that one. It's really up to you. So for y, I'm substituting that 2. For m, which is the gradient, I'm substituting the minus 1 that we got. 2 is also going to be 2 plus c. 2 is equals to negative 2 plus c. Transpose the 2, we get a 2 plus 2. C4 is equals to c. Therefore, the equation is going to be y equals to minus 1x. C, it's that 4. There we go. That's the equation for that curve. I mean, for that tangent at that given curve. 2.3, kinematics or motion, or a question involving motion, application for differentiation. The graph below represents the motion of an object moving according to the formula S of t is equals to minus t cubed plus t squared plus 5t plus 3, where S is distance in meters and t is time in seconds. The point B is a turning point. That's very important. That's going to come in handy. Let me just highlight this. This is a turning point of the graph. As a turning point on the graph, okay? So let me just go back. No, I don't need an eraser. I need this. Okay, so that's B. 2.3.1. Determine the distance traveled after 1 second. So this is just a matter of substituting, because already that formula, it's a distance formula with time as the function, right? So we're gonna have a minus t, so I'm just rewriting that formula, t plus 3. So with this t, I'm just gonna substitute 1. So S of 1 second, it's minus 1 cubed plus 1 squared plus 5, 1 plus 3. Okay, therefore we're gonna have a negative 1 cubed plus 1 squared plus 5, and then that's 1 plus 3. Okay, that's 8, 9. Take away 1, we're gonna have an 8 as an answer. So that's 8 meters as the final answer. Okay, therefore 2.3.2, determine the velocity of the object at t equals to 2 seconds. Okay, so the first derivative of a distance formula gives us a velocity. It's gonna be the velocity, so that's minus 3t squared plus 2t plus 5. So the derivative of 3, it's what? It's gonna be 0. Okay, so I was differentiating the distance formula so that we can get velocity. So S prime also represents what? The velocity. The velocity. So this is gonna be S prime of 2 seconds. This is minus 3 2 squared plus 2 2 plus 5. Negative 3 2 squared plus 2, okay, it's 2, not 1. It's 2, not 1. It's 2 plus 5 equals to negative 3. Negative 3, really? Yeah, it's negative 3. It's negative 3. So it's slowing down. Meters per second. Meters per second. Use your graph to write down the values of t for which the velocity is negative. For which the velocity is negative. Use your graph to write down the values of t for which the velocity is negative. Okay, so 2.3.3. okay, look, this is the turning point. This is the turning point. At the turning point, F, in fact, let me just use the notations that are given to us. So S prime of t at the turning point, it's going to be 0. The 0 gradient when our tangent is a horizontal line. Okay, so at the turning point, S prime of t is equals to 0. This is where we get the okay, not the maximum, but where velocity is equals to 0. Okay, is equals to 0. If your tangent is tilted like this, you get a gradient that is positive or greater than 0. Okay, so from this point going all the way up along the curve, we see a positive gradient for all the tangents that are placed along the line. Okay, so it means that the function is increasing from this point A to point B. So the velocity, we say, it's constantly increasing all until it reaches 0, right? It increases until reaching what? 0. Yeah, until reaching 0. Wait. Okay. What am I saying? The velocity is not increasing. Oh, okay. You know what? I don't want to get too much into the physics of the problem, né? But just understand that from this point A to B, the velocity is positive. Okay. From B, let me just use a highlighter and say, from B going all the way down along this curve, we're gonna get a negative velocity. Why? Because the gradient of the curve, it's gonna be negative. So S prime of t is gonna be less than 0. So use your graph to write down the values of t for which the graph is negative. So it's negative from point B to infinity. So we're gonna say t should be greater than, in order for the velocity to be negative, t should be greater than 1, 2 over 3. Where am I getting this? I'm getting it from the point of the turning point. This, when t is greater than that, we see a velocity that is less than or negative. Okay, and then 2.3.4, determine the maximum velocity of the object. Maximum velocity. Okay. All right, how do I explain this now? Okay, so the velocity is a maximum. Let me just write this down. Velocity is a maximum. It's a maximum when acceleration is equal 0. So we need to find the acceleration. So let's derive a formula for the acceleration. So an acceleration, it's a second derivative of the distance formula. So we're gonna take this, differentiate again. So it's gonna be s double prime of t equals to negative 6t plus 2. Then we equate to 0, we calculate t. We're gonna get a 6t equals to 2 divided by 6, cancel, t is equals to 1/3, 1 over 3, 1/3. And then we take the 1/3, since we want the maximum velocity. So we're gonna go back to the s prime t. This is the velocity formula, isn't it? Plus 2t plus 5. S prime of 1 over 3, we substitute 1 over 3 squared plus 2, 1 over 3, and then it's minus 15. We then calculate, that's negative 3, negative 3, 1 over 3, and then raised to exponent 2 plus 2, 1 over 3, minus 15. Minus 15. No, it's 5. It's 5, not 15. It's 5, 5. get a negative 14 over 3, which is negative 4,67 meters per second. Why even negative? Oh, okay, it's plus 5 plus 5. What did I do? Plus 5. Yeah, it makes sense now. Now it makes sense. It cannot be negative. It should be positive. So that's where we get a 16. Okay, negative, sharp, positive. Okay, yeah, 16 over 3, which is 5,33 meters per second. This is the maximum velocity. Okay, that's question 2. If you are enjoying content, leave a like, man. Leave a like. Subscribe, subscriber. Alright. Okay, so this is question 2. Let's jump to question 3. But first, let's get rid of this writing. Okay, now let's start with question 3. Question 3. Now question 3 is all about the integration. So we see a set of integrals, indefinite integrals. We're going to do them, and we have another special kind of integral, and we have a area under a curve. Okay, this is even an area under a curve. So for question 3.1.1, the first integral, they want us to integrate of 15x squared minus 3 over 2 square root x plus 4e 2x plus a 2 sec 3x squared dx. Alright, and then I close off that bracket as well. Alright, so what should happen with this problem? We need to do some simplifying again, just like a good differentiation. I did explain or say something about a root blocking the integration process, as well as a bracket. There's a bracket that's stopping the integral from taking place. And another thing with the x is also forming part of the denominator, so we need to get rid of the root, x as a denominator, and the bracket. So we are not integrating as of yet. We are just simplifying. So this is going to be a minus 3 over 2 x raised to exponent minus a half. The half is for the square root, the negative is for the fact that we need to move x from the denominator to the side, plus 4e 2x plus, you need to be careful when solving this bracket. This 2 affects that 2. This 2 then affects the sec as well. Alright, it then affects the sec. So the 2 is going to be squared. We get a 4. The sec 3x is going to be squared as well. So we're going to get a sec squared 3x, close bracket, dx. Now we can perform our integration. So with the integration, we add 1 to the numerator. Whatever result we get, we divide with. So 2 plus 1, that's 3. So it's going to be 15 over 3 x 3 minus 3. Okay, the negative half, we're going to add 1. A negative half plus 1, we get a half. So it's going to be a 3 over 2 divided by the half we got after adding by 1. So it's a half. Negative half plus 1 is a positive half. Plus, when we integrate, whatever we integrate or even differentiate the e function, nothing happens. Nothing really happens. But we're going to take the coefficient of x over there and divide it by, and divide 4 with. So it's going to be a 4 divided by 2e 2x. Where's the 2 coming from? It's this 2. Then we're going to say plus 4 over 3 tan 3x plus c. So what I'm basically doing, I'm applying this. These are differentials. Let's look at this one for instance. So 26, we have the integral of e raised to exponent kx. So whenever we integrate an e raised to exponent kx, we take the k we divide with, and then e raised to exponent kx on the numerator. Okay, same thing applies with let me check. Right, the integrals, they are not written the way I expected it to written, but yeah, that's the whole idea. So even whatever value that you get as a coefficient of x inside a trigonometric function, you also divide with whenever you integrate. Okay, so equals to 15 over 3, I think it's 5. And then it's minus 3x. Okay, so that's going to be square root x. Remember, we need to rewrite it in SAT form. So that's going to be square root x. 3 over 2 divided by a half. You punch this on the calculator, you should get a 3 plus 4 over 2. That is 2e2x plus 4 over 3 tan 3x plus c. Done. 3, 1, 2. So we have the integral of 4 cos 2x plus x over 2 minus 2 over x plus 3 dx equals to, okay, okay, that is a half. All right, okay. All right, you know what, I don't want to say there's nothing to solve here or to rearrange. Let's not rush it. Let me just gather my thoughts for a moment. Okay, here we go. Now let's not integrate right away. So we're gonna write this as cos 2x plus 1 over 2x on the side. Just make sure the x is on the side, and then you're gonna have a minus 2 1 over x. Let me rewrite this thing like this. Now this is a special case. We cannot say because x is a denominator, let's put it on the side. It only applies for integration. When you have x raised to exponent 1 as a denominator plus 3, just write it like this. Isolate the x as 1 over x, because we know that from principle, an integral of anything divided by x, it's the ln, right? It's the ln. So 4 cos 2x, that's gonna be a 4 over 2. We take whatever we find here next to the x, so this is going to be a 2x. Integral of this, it's going to be 1 over 2. 1 plus 1, that's 2. So it's x raised to exponent 2 divided by 2 minus integral of 2 1 over x. It's 2 ln x. Ln x plus the integral of 3, it's just going to be 3x plus c equals to 2 sine 2x plus 1 over 4 x squared minus 2 ln x plus 3x plus c. That's the final answer for this one. That is the final answer. Then for 3.2, the velocity equation of an object is given by meters per second. What is where t is the time in seconds? Determine the distance traveled during the third second. Velocity equation is given by this. Okay, apply integration to solve the problem. The area below the velocity graph gives the distance. So we need to take this velocity, integrate it so that we can get the distance formula. So we're gonna integrate v. This is equals to the integral of 3t plus 5. So we're gonna integrate we're going to integrate the function of v with respect to t. So this is going to be equals to the integral of this. It's 3 over 2t squared plus 5t. There's no need for the c. And then they want us to calculate the distance within the third second. Okay, within the third second, determine the distance traveled during the third second. Okay, I need to be careful. I need to be very, very careful. Why am I saying I don't need the C? Okay, don't we need a C for this one? And what do they mean by third? Okay. All right. Okay, check this out. This is a very, very, very tricky question. First, second, it's the difference between T1 and T2. When time is 1 and when time is 2 seconds, that's the first second. The second during the third second. Yeah, okay. No, the phrasing of that question is very, very, very tricky. Then the second, it's this. From T2 to T3. Third second, I think you see the pattern by now. No. It's from the first second, it's 1 to 2. And then this is 2 to 3. Okay. Oh, no. This should be 0 to 1. And then 1 to 2. And then this is 2 to 3. That's what we mean by the third second. So it means that this is not going to be an indefinite integral and it's just us going ahead and substituting t as 3. It's the third second. Not after 3 seconds. It's the third second. So we're going to have boundaries of 3 and 2 right here. So after integrating, we're going to have a boundary again as 3 then 2. And then we go ahead and substitute 3 over 2, 3 squared, 5, 3, minus 3 over 2, 2 seconds, 5, 2 seconds, equals 2. And then we go ahead and calculate. Yeah, this is rather unexpected. Came unexpected, this question. 3 over 2 and then 2 squared plus 5, 2 close, we get a 12,5. 12,5. The 12,5. Okay. Then we jump to the next question, the 3.3, which is the last part of the question. And then they want us to, okay, given the graph of f of x, okay, this is the integral that we did. Still remember the integral that we, no, not an integral, but a derivative that we did over here. Now, the first question, 3.3.1, use the addendum. So we're not going to use the addendum because it's already given to us. I mean, we're just going to show the thingy here. And show the representative strip that you will use to calculate the area, to calculate the shaded area. So you're just going to draw a vertical strip like this. Okay, let me use something proper, man. This is our representative strip. The representative strip should be drawn somewhere in the middle of the area, like this, like this, like this, like this, like this, like this. So this is the representative strip. The representative strip, it's sort of like a portion of the graph or a strip that we use to work out the area, right? So calculate the magnitude of the shaded area. So we're just going to take the integral again and treat this as a indefinite integral, upper bound, lower bound. Okay, so therefore we're going to integrate f of x. In fact, let's start off by writing it like this. Area is equals to the integral of, should do dx right here. So it's the integral of f of x multiplied by dx. So the area, okay, then here it's b, then it's a, this is our b, this is our a, the upper bound and the lower bound. So the upper bound, it's that 4, lower bound, it's 1, f of x, it's this 4 over x dx. Then we integrate, we get a 4 ln x. We close it off, we put in the bounds, that's 4 and 1, equals to 4 ln 4. And then we're going to have a 4 ln 1. Then we say 4 no tan ln of 4 minus 4 ln 1, close bracket. Then I get a 5,545 units squared. That's our question 3. Question 3, it's all about integration. Then we're gonna do question 4. We have a cubic function, there's some polynomials, yada 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 yada, and a function. Yeah, okay. Let's just erase and do the question 4. Now for the question 4, we are given a graph that is represented by a third degree polynomial f of x equals to that, which cuts the x-axis at a, b, and c. That is the graph. Apply the factor theorem and long division or any other method to calculate the x coordinates of a, b, and c. So what we're going to do, we're going to say question 4, Q4, that's question 4, and then we have 4.1.1 where they want us, or 4.1, it's 4.1. Alright, so 4.1 where they've given us so f of x equals to negative x cubed minus 2x squared plus 5x plus 6. This is what we have. So let's apply the factor theorem and the long division. But I'm not going to use the long division. I'm going to be using a synthetic method to get the x coordinates. Okay. So first things first, I need a calculator. So I need to find a factor. I need to find an x value that when substituted gives me a 0. That's going to be our first factor. So minus, let's start with positive 1. So positive 1 cubed minus 2 1 squared plus 5 1 plus 6. I'm getting an 8. What about to minus 1? Minus 1, come on. Minus 1, I'm getting 0. Alright, so when x is equals to a negative 1 and substituting it into that equation, minus 1 cubed minus 2 negative 1 squared plus 5 negative 1 plus 6, this results as a 0. Therefore we're gonna say that that is a factor. That's the first factor. Okay, so we're gonna take this minus 1 and do a synthetic method with it. So I'm gonna take the coefficient of x cubed, it's negative 1, the coefficient of x squared, which is negative 2, the coefficient of x, that is a plus 5, and the constant 6. And then we drop the negative 1, we get a minus 1. The negative 1 times the negative 1 gives us a positive 2. I'm gonna write it here. And then we add these two, I get 0. I multiply these two, le times lena. Okay, you know what, let's continue. So negative 1 times 0, I'm getting a 0. We add, we get a plus 5. No, something is not right. Something is not right. Let's check. Negative 1, negative 2 plus 5 plus 6. Okay. So am I sure when I substitute the negative 1, okay. Yeah, that's a plus 5. Yeah, that's a negative 2. And a plus 6. Yeah, it's 0. 0. Drop, multiply, we get a positive 2. So that's a negative 2. X squared, okay. Multiply, we get that. 0. Multiply, we get 0. No, something is not right. What am I missing? Minus x cubed minus x squared plus 5x plus 6. Minus 1, minus 2, plus 5. Okay. Okay, I see the mistake now. So the mistake is that I added the 1 and the 1. So the negative 1 times the negative 1, it's a plus 1, not positive 2. Alright, so therefore we add, we get a minus 1. And then we multiply again, we get what? We're gonna get a positive 1. Add, we get 6. Multiply, we get negative 6. Add, then we get 0. That makes perfect sense. Alright, so therefore we now have a minus x squared, a minus x, and a plus 6 equals to 0. It's coming from this, and that one. That's a trinomial. But I'll have to divide throughout by a negative 1 so that I can apply the factoring method for simplifying trinomials. Positive x squared, positive x minus 6 equals to 0. 2 brackets equals to 0. X plus 3 and a negative 2 like this. Therefore, x becomes negative 3 or x becomes positive 2. Now we have our 3 factors. we now have our three factors. This is the first one that we identified initially, and we have another one, x equals to -3, and a third one. Okay, so the coordinates for a it's this one, so a should be the -3 and 0, and then we have the second one, which is b. It's gonna be -1 and 0, and c, it's gonna be the 2 and 0. So we have our coordinates a, b, c. Now 4.2 is factor remainder theorem. Okay, factor remainder theorem. If you're enjoying the content, like, share, and subscribe. Okay, so when f of x is divided by x minus 3, the remainder is 10. Calculate the value of k using the remainder theorem. Okay, so an easy grab, we have the f of x, that is equals to an x cubed minus kx squared minus x plus 13 divided by x minus 3. We take that, equate to 0, and solve for x. We get 3. X is equals to 3. Right, so we have a remainder of 10 whenever we substitute x equals to 3. So we're gonna say f of 3 is equals to 3 cubed minus k 3 squared minus 3 plus 13 equals to, so whenever we substitute the 3, we're gonna get a remainder of 10. So this is 27 minus 9k. This and this gives us a plus 10. So the 27 and the 10 gives us a 37 minus 9k. Transpose of the 9k, we get a 9k, a positive 9k. A 37 minus 10, 27 is taking me back to 27. Dividing both sides by 9, that k becomes 3. That k becomes 3. And then 4.3, the expressions, this one, let me just highlight. Yeah, all right, these are the expressions. This expression and this one have the same remainder when divided by x minus 2. In the same light, also x equals to -2 is a root of this okay, it's an equation of this equation. It's a root of this equation. It's a root of this equation. And then they come back and say, use the information by applying the remainder theorem to calculate a and b. So we're gonna have a simultaneous equation, okay? Because there's two unknowns, and we're gonna end up having two equations. But first of all, let's start with the purple, this part. Let's figure out what we can do with that. So since the x equals to -2 is a root, when I substitute the -2 into that equation, I'm getting a 0. So we can just go straight to this equation. This x cubed plus 3a squared plus bx minus 6 is equals to 0. We substitute that -2, -2 cubed plus 3a minus 2 squared plus b minus 2 minus 6 equals to 0. So that's giving us a -8. Let me just confirm. Yeah, -8. And then this is 4 times 3. We're gonna get a positive 12a. 3 times -2 squared. Yeah, that's 12a. And then we're gonna have a minus 2b minus 6 equals to 0. So the -8 and the -6 are giving us what? A -14. So we have a 12a minus 2b minus 12, 14 minus 14 equals to 0. 12a minus 2b is equals to positive 14. That's our equation 1. Alright, have the same remainder. Okay, for the yellow part now, these two expressions have the same remainder when divided by x minus 2. X minus 2 equals to 0. X is equals to 2. So we're going to substitute the 2 into this and this. The result are going to be giving us what? Okay, we're going to equate the results. So I'm taking the first equation, the 2x cubed, I'm putting in 2 cubed, minus 5, I'm putting in 2 squared, plus 2a, I'm putting in 2, plus 52 is equals to the x cubed. In that x cubed, I'm putting in 2 again, cubed, plus 3a, I'm putting in 2 again, squared, plus b, 2, then negative 6. Like they said, the expressions have the same remainder when divided by x minus 2. So whenever I substitute the negative 2 into that expression and substituting the 2 into that expression, the two expressions are going to be equal after substituting by the 2 because they have the same remainder. Let's simplify. 16, then that's gonna be 20, yes, 20, so that's negative 20, and then we're gonna have a plus 4a and a plus 52 equals to 8, and then that's 4, so that's gonna be a plus 12. Oh, the same as that one. Okay, so that's gonna be a 12a plus 2. Okay, plus 2b minus 6. This, and this are like terms. So the 16 minus 20 plus 52, that's 48. So this is going to be 4a plus 48 equals to 8, negative 6. 8, negative 6, that's positive 2, plus 12a plus 2b. Okay, what can we do? Okay, I'm gonna bring the 2 this side and take the 4a over to the other side. So that's gonna be a 48 minus 2, and a 12a plus 2b minus 4a. This is gonna be 46, and then 12 minus 4, that's 8a plus 2b. There we go, equation number 2. All right, so I think we had a simultaneous equation way back when. Okay, I ended up erasing it. This simultaneous equation in question 1, where we were doing this, we ended up with a simultaneous equation, and I used the substitution method to simplify. So here's another simple simultaneous equation. For this one, I'm going to try something different now. If you are watching question 4 as an isolated video, not the full recording, check out the description box. There's going to be a link for the full recording of the question paper. So this recording continues from that whole discussion. So check again. Equation 1 and equation 2, we're going to solve these simultaneously, but this time I'm using the elimination method. So how does it work? The elimination method, I'm going to try to cancel out one of the variables by adding or subtracting the two equations. Take a look at the okay, sorry to cut off the recording. There has been a technical error during the recording of this video. So I took a screenshot where I left, and we're going to continue from there on. Okay, so the conversation ended where I was talking about the elimination method and cancelling out our variables. So I was on about this negative 2b and that plus 2b in the second equation. So we're going to eliminate these two variables. We're going to eliminate the variable of b. So we have 1 and equation 2. So we're going to take the first equation, which is 12a minus 2b equals to 14. So this, I'm going to write it on the left hand side like this. And a plus 2b equals to 46. Then I'm going to take these two equations and add them so that we can eliminate one of the variables. In this case, it's going to be the b. So 2a plus 8a, that is 20. 20a. This, when added to that, they're going to cancel. 14 plus 46, that's 50, that's 60. Then dividing both sides by 20, 20, they cancel. A is now equals to, I think it's 3. Yes, that's going to be 3. And then calculating A, we're just going to go back straight maybe to equation 1 or equation 2. It's really up to you. Then for this discussion, I'm just going to go back to equation 2. 8, and in A, I'm substituting 3 plus 2b. 46, 8 times 3, 8 times 3, 8 times 3, that is 24 plus 2b. 46 minus 24 is equals to 2b. Then we subtract, okay, 22 is equals to 2b divided by 2 divided by 2, 11 is equals to b. Okay, so this is A, this is B, solving that 4.3 simultaneously. Okay, so we're gonna jump to the last part of the question of 4.4, but first let me just erase this part so that we can have enough space to write on. Alright, so the 4.4, we are given a diagram below that shows the graphs of f. This should be f of x equals to 2 raised to exponent x, and g of x equals to ax squared. The point C lies on the graph of g, so we have an exponential and a parabolic graph. So for the first question, 4.4.1, calculate the value of a. So we have g of x, that is equals to ax squared. Y equals to a squared. They want us to calculate a and determine the inverse of g in the form y equals to. So in order to calculate the a, I'm going to be using the coordinate or the point 1 and minus 4. So we're going to substitute for a, okay, it's minus 4, and then 1, it's not negative 1, and then 4, 1 squared, it's 1, so it's just going to be simply a. Therefore, the equation is going to look like this, minus 4a x squared. Alright, then we're going to get the inverse, that's g minus. We swap the variables around, we're going to have an x that is equals to minus 4y squared, dividing both sides by a minus 4. Cancel, cancel. We're going to have an x that is divided by 4 equals to y squared. We square root, we square root. Therefore, y is equals to a plus minus square root of x over negative 4, like this. Okay, so that is the inverse. And then for the 4.4 4.2. Let me write it on this side. We're gonna have a 4.4.2. Write down the domain and range of that g function. Okay, let me have a straight line that goes like this. So the domain it's this. The domain, it's gonna be x element of, remember the domain, we capture all the x values that form part of the given graph. Okay, so looking at the parabola, it stretches out like this and stretches out like that. So it stretches all the way up to infinity across the x axis. So we're gonna have a negative infinity and a positive infinity with over brackets around, because we exclude the infinity signs. And then for the range, it's y element of. So we study the y-axis just to check how the function is stretching out along the y-axis. So it starts here, we mark where it starts and where it ends. In fact, it starts at 0 but stretches out to negative infinity. Okay, so when we write the range, we're going to start with the smallest value. In this case, it's the negative infinity, and it ends at 0. Right, if we say it starts from here going up, it ends where? At 0. So the range is going to be negative infinity to a 0. So that is the range. And then 4.4.3, the graph of g is symmetrical about the x equals to 0. So the x equals to 0, it's actually the y-axis. X equals to 0, that is the x-axis. A y equals to 0 represents the x-axis. So, but this g graph is symmetrical about the x equals to 0 line. You see this purple line, the y-axis, that is where the parabolic graph is symmetrical about. Now the question is, or the instruction is, to write down the equation of the line of symmetry of the inverse function. So the inverse function is going to look like this. It's going to look like this. Okay, so if the inverse function looks like that, don't you think that the symmetry line is going to be the orange line, which is the x-axis? So they want the equation for that x-axis, which is y equals to 0. And for the 4.4.4, we need the inverse equation of f of x. So this is f of x equals to 2 raised to exponent x. So we need the inverse in that form, x equals to, so this is y equals to 2 raised to exponent x. Let's get the inverse. So that's f minus 1, and then we invert the variables. We're going to get an x that is equals to 2 raised to exponent y. That is the inverse function. And then they want us to sketch the graph of the inverse of f. Nice. Okay, let me go grab let's go to the addendum. All right, so the addendum gave me this. This is the addendum for 4.4.5. Okay, so we want to plot the inverse function of f. This is the f function that is given to us. Okay, so the inverse function is just going to be a graph that is reflected about this line. Let me check if I'm capturing the right 1 to 2. Okay, it's okay. Maybe let me start here. 6. Okay, let's start maybe with 5, then 5. Yeah, I'm gonna capture the right thing. Perfect, perfect. So this is the line of reflection, y equals to x. Okay, so maybe let me use red to plot this one. So this is point number 1, point number 2, another point here, another point. All right, maybe let's get the coordinates for these ones. I know that I teach, or I taught the plotting of inverse graphs by starting off by getting the table of the original graph, and then you switch around the variables so that you can get your inverse. But in this case, there's no need to do that because you already have a graph, so you can use what you already have and switch them around. Like in this case, we can actually pinpoint coordinates like the 2 and 4 and that 3 and 8, and then we have 1 and 2 and 0 and 1, like this. Okay, then we're gonna invert these coordinates. So this 3 and 8, it's gonna be an 8 and 3, 8 and 3. There we go. This 2 and 4, we're gonna change it around to be a 4 and 2, 4 then 2, and then this 1 and 2, it's gonna be 2 and 1, and then this 0 and 1 is gonna be 1 and 0, and then we connect everything like this. We connect everything like this, and then we have f minus 1, 8 and 3, 4 and 2, 2 and 1, 1 and 0. So that's the inverse graph of the f. And they wanted us to show clearly the intercepts with the x-axis and at least one other point. So we went beyond. We went beyond. Now for the next question, 4.4.6, about which line are f and the inverse graph symmetric? They are symmetric about this line y equals to x. Write down the domain of f minus 1. Oh, okay, so it's 4.4.7. 4.4.7. Write down the domain of the inverse function. So the inverse function has the following domain. So the domain, we only check the x-axis. So the domain starts at 0 and ends at infinity. All right, so x element of domain, we don't include the 0, by the way. We don't include the 0 because the 0, when x is 0, we have the asymptote. So it's 0 excluded to a positive infinity like this. That is the domain. And 4.4.8. 4.4.8, Elena gives the range for f. F, it's this black graph, this one. Elena gives the range of f as y element of 0 to infinity for y a real number. Explain why the Elena is wrong. To approach this problem, I would say maybe let's go ahead and try to figure out the true range for the f function. So the range, what do we do? For the range, we check the y-axis. So along the y-axis, we see that our graph starts where? From the x-axis, and then it stretches up like this. It never jumps the x-axis. So that means the x-axis for that black graph or that green graph is actually when y is equals to 0. Yeah, when y is equals to 0. When y is equals to 0. When y is equals to 0, we see that we get an asymptote. So from the asymptote to infinity, that is our range. So the range is going to be y element of the 0 we don't include because it's an asymptote. It starts at 0, but we don't include the 0 because it is an asymptote, and then it continues to a positive infinity like this. Okay, so that is our range. That is our range. However, this doesn't answer the question. Let's go back and check or compare our answer with what the learner wrote. You see what he did, or what she did. She used a square bracket, and in fact it was supposed to be a oval bracket. We weren't supposed to include the 0. That is why his range is wrong. Okay, so that's the reason for the last question, question 4. Okay, so this is where we end question 4. If you are watching question 4, like, share and subscribe. But this question 4, it's part of one consolidated recording for the whole question paper of this supplementary 2018. Check out the description box. There's gonna be a link for the full recording if you are only watching question 4. But if you are watching the full recording, let's jump to the next question, question 5. Okay, let's wrap this up with question 5. 5.1. A paint shop mixes two different colors, yellow. Let's perhaps maybe highlight as yellow, yellow, yellow. So that's yellow, X liters, and red, that's Y liters, to get to a different shades of orange. Let's perhaps highlight that as orange. I'm writing over that. I want to highlight as orange, not red, but orange. An orange shade of gray. A shade of orange. Now, the shaded area in the diagram represents the feasible region subject to a set of constraints under which they can mix these colors. So we have that graph. We have a set of constraints. I think it's 4. We have 1, 2, 3. In total, we have a set of 4 constraints. And then for 5.1.1, given is the constraint. So we are given this constraint 5 less than y less than 25. Use the information above to write down constraints associated with F and H. So perhaps we can draw a line that goes like this by highlighting. So that is H and this is F. So these are the only constraints that we need. So the two horizontal constraints, Q, no G, are given by this constraint, right? I remember back last year, level 3, I think a question came, linear programming, where they had to plot a constraint that was somewhat similar to this. I don't remember if there was a y or an x in between the two values, but I saw that my students were, like most of them, they failed to like interpret what was actually happening. So this constraint can be broken down into the following: into y less than or equals to 25 and y greater or equals to 5. Then you plot, you just break it apart like this. So when you grab this part of the inequality, you just change the direction of the sign and then you place y on the left hand side. That's what I did. Or you can leave it like this and interpret it the following way. So if you were to plot something like this, you're gonna start by plotting a horizontal line for 5. So you're gonna have a 5 right here, a 5 right here. Then you're gonna have a 25 over there. You draw a horizontal line over the 25. You draw a horizontal line over the 5, right? Because the inequality sign is less than y less than. So it means that the feasible region, it's gonna be drawn between these two lines. Okay, it's gonna be drawn between these two lines. That's just me breaking down that constraint. Okay, so we need to pull out the constraints for the green line as well as the gray line. So H, let's start with the green. H, the the constraint is going to be, since it passes through 10, so it's going to be x greater or equals to 10. It's greater or equals to 10 because the feasible region is to the right of the green line. And then we're going to have f as well. F, it's that line which intersects with the x-axis at 45 and intersects with the y-axis at 45. How do I know? Because this point is right in the middle between 40 and 50. Same thing can be said about this point. Hence, I'm putting a 45 and a 45 right here. So the constraint for the F line is just going to be x plus y and a 45 on the right hand side. But what about the direction of the inequality sign? It's going to be less than or equals to. Why? It's because of the feasible region is below that line. If it was above the line, it was going to be greater or equals to. Greater or equals to. So another way of working around this would be to do this. There's a formula that I use, x over a plus y over b equals to 1. We only use this formula if we want to find the equation of the of an inequality, where we know the y-intercept as well as the x-intercept, right? So, or you can apply this one, but this one it takes a bit longer to get the actual equations. The y equals to mx plus c. This one takes a bit longer because you need the gradient. You also need the y, the value for c as well. So this is the quick way out. This is the quickest way. So look, x over a, y over b. You only have to substitute the b and the a values. Then you work out the equation. So we have x. The a represents the x-intercept. So the x-intercept is 45. Plus the y over b. B, we're going to substitute the y-intercept. It's also 45, equals to 1. Since the denominators are the same, we add the numerators and take only one denominator equals to 1. And then we divide by 1, we cross multiply, or we just multiply by the LCD, which in this case it's 45. And then this side we also multiply by a 45. So 45 cancels out 45, we get an x plus y equals to 1 times 45, that's going to be a 45. There we go. There we go. It's the same as that one, except we have an equal sign. So we need to remove the equal sign with the proper inequality sign. You check where the feasible region is. If it's below, less than or equals to. If it's above, it's greater or equals to. If the intercepts are not the same, let's have a case like that one. Nyanfaga man, nyanfaga, ungawari. X, let's say maybe we have 50, right? I'm changing the problem now. I want to show you a case where the denominators are not the same, or the intercepts are not the same. It's still going to work out. And then let's put maybe a 60 right here. So the x-intercept is 60, so I'm dividing x by 60, plus the y-intercept is 50, so I'm dividing by 50 equals to 1, all right? Depending on how you handle fractions, use that method. So you need to handle the fractions on the left-hand side and then simplify from there. So you get your LCM and then you multiply each and every term in the equation. Then you remove the fractions, then you work out by making y the subject of the formula or leaving the variables on one side of the equation. So I'm going to use the butterfly method where I take the 50 multiply x with it. I'm getting a 50x plus the 60 multiplies the y, I get a 60y divided by, and then I multiply the 60 with the 50. 60 times 50, I'm getting 3,000. 3,000 is equals to 1. And then I'm going to multiply by 3,000 3000, they cancel. I'm gonna be left with 50x plus 60y equals to 3000. 3000. Then looking at the feasible region, since it's below, I'm gonna say less than or equals to 3000. But this can be simplified further if you want to, but it's not really that necessary. There's a common factor of 10. You can take it out and divide on both sides of the equation, but it's not really that necessary. So you can just leave it like this. You can leave it like this. All right, so that's enough about that equation in extracting or getting your inequalities. So we have the answer as x plus y less than or equals to 45. And then the 5.1.2, let me go back to black. If the paint suppliers only have 30 liters of yellow paint, maybe let me highlight. It's gonna come in handy. 30 liters of yellow paint, and then there's also 15 liters of red paint. Now the question is, will they be able to supply the orange paint that satisfies the prescribed constraints, the ones that we have above, the ones that we calculated calculated above? Verify your answer by applying the inequalities in 5.11. So we have two inequalities that we got. It's that x greater or equals to 10, and the other inequality, this one, 45. All right, so the only time that a set of coordinates satisfy a number of prescribed constraints, it involves you substituting the given coordinates. Like we have 30 liters of yellow paint, that's x. We have 15 liters of red paint, that is y. Okay, so looking at this, or rather starting with this constraint, I'm going to substitute x. X, it's 30. 30 greater or equals to 10. And indeed, 30 is greater than 10. Okay, not equals to 10. 30 is not equals to 10, but it is greater than 10, right? Because this inequality sign is greater or equals to. So indeed, the 30, it is greater than 10. So the first inequality is satisfied. Let's check the next one. In the place of x, I'm substituting 30. In the place of y, I'm substituting 15, less than or equals to 45. 30 plus 15, that's 45. Less than or equals to 45. Listen to what I'm saying. Less than or equals to. So indeed, the 45 is equals to a 45, right? Is equals to a 45. So therefore, this one is also satisfied. Satisfied, there's no S. It's satisfied. It is satisfied, as well as this one is satisfied. So this is how we prove that the given quantities can actually satisfy the prescribed constraints. So that's 5.1.2. Jumping to the next question. So with linear programming, questions can come in two forms, where you are given a graph for you to interpret, or you can be given a statement for you to take out constraints, and then you end up plotting the graph, right? So this is a classic example of such a question in linear programming, where you have a graph, interpret, that's the 5.1 that we were doing, and then a 5.2 where, for a 5.2 where we have a question that wants us to plot the graph. But first, there's a statement that needs to be interpreted first. So we have a tourist group that wants to stay over for 1 day at the Eland Spa Resort and must book their accommodation in advance. The resort has a choice of two types of chalets or cottages. So we have type A. These chalets can host a couple and has a double bed. Nice, very nice, very nice. So the type A, it's for the couples, laba bathandanayo, yeah. And then type B, we have these chalets that can host a family and has a double bed and two single beds. So there's a group of tourists that are coming over. It's not only couples, right? It's not only couples, but there's also a group that came as a family, right? So lucky for them, there's a chalet that is accommodated, or that can accommodate families as well. So in the group there are at least, okay, we need a highlighter for this. We need a highlighter for this. We need a highlighter for this. In the group, there are at least 4 couples who want to stay in the type A chalets. There are okay, let me just read the statement first, then I'll highlight after the second read. And they want not less than 4 of the type B chalets to place families with 4 members. The ratio of type A to type B must be at least 1 to 2. The group needs 18 chalets at the most. Okay, that's the first read. I kind of have a fair understanding of what's happening, but a second read maybe might help us crack this down. So now I'm going to reread, but at a slower pace. In the group, there are at least 4 couples who want to stay in the type A. So we have 4 couples. Let's highlight. Let's highlight. In the group, there are at least 4 couples who want to stay in the type A. Of course, the couples, they're going to end up in type A chalets, and they want not less than 4 of the type B chalets to place families of 4 members. There we go. We highlight this part. Why? It's giving off a constraint. So the first highlight, it's constraint number 1. The second highlight, that's another constraint. Let's get another highlight. Okay, here we have a ratio of type A to type B. A ratio of type A to type B must be at least 1 to 2. Okay. Okay. The term phrase, when we mention something about a ratio, just think of a fraction. Think of a fraction. A ratio of A to B, it's A divided by B, basically. So the group needs 18 chalets at most. Again, here's another chalet. At most 18. Okay, at most 18. So I suspect we're going to have 1, 2, 3, 4 constraints in total. So for the 5.2.1, or another thing, they want us to let the number of type A chalets to be X and the number of type B to be Y. So for 5.2.1, 2 types of constraints. These are the implicit constraints. Model the other constraints in respect of the above information in terms of X and Y. Let's go ahead and do that. So the first one, in the group, there are at least 4 couples who want to stay in type A. So type A is represented by X. There's at least, so at least translates to a greater or equals to in equality sign. So at least 4. Then it continues. They want not more. Okay, they want not less than. They want not less than. So it means that I don't want less than 4. I want more than 4. So we're gonna say Y for the B type chalets greater or equals to 4. 4 members, right? For 4 members of the chalets, they want what? More than 4 of the chalets. So the moment a family comes and books an accommodation, or the group books an accommodation for one of the families, and then they find that the family has two, that's a couple, 3, 4, 5, maybe, that is considered a family. So we need to book for what? For the chalet type B. So that is why the y is greater or equals to 4. Ratio of type A to type B must be at least, again, at least that's greater or equals to. So the ratio of type A to type B, so it means that type A, it's x over y. The ratio of type A to type B is at least 1 to 2. 1 to 2. Now, we can't leave this constraint like this. It's either I leave it in terms of y being the subject or x being the subject, right? So ideally, we'll have to simplify this and leave it in terms of y being the subject of the formula. So we need to simplify this a bit further by saying y times that and 2 times that. We are cross multiplying, so the x is gonna land on the left hand side, and then the y, this is gonna be 2x, because 2 times x is 2x. It lands on the left hand side, and then the y lands on the right hand side. And then when we make y the subject, we're gonna end up having a negative y greater or equals to a negative 2x. Dividing both sides by a negative, the y should stay positive, right? So dividing by a negative on both sides of the equation changes the direction of the sign. We end up with the y that is less than or equals to 2. Constraint 1, constraint 2, constraint number 3. Let's get the last one. The group needs 18 chalets at most. X for type A, Y for type B. Combined, at most, we need 18. So at most translates to a less than or equals to inequality sign. So that is constraint number 4. As suspected, we're gonna have 4 constraints. So for the 5.2.2, there's a tariff for type A is this per day, type B is that per day. Write an equation that represents the total cost for the stay in terms of x and y. So the cost is going to be equals to the tariff for type A, it's 1,000 rand. We multiply that by x, the number of type A, plus 1,500 rand for the type B. So this is the cost equation in terms of x and y. 5.2.3. Determine the gradient for the search line. Show all the steps. So we're going to take the cost. Because the search line is found or calculated using the objective function. So the cost equation, it's actually the objective function. The objective function, its basic purpose is it's going to help us to maximize, because the objective of this problem is to actually minimize cost, or discovering or finding out what are the optimal cost or the maximum cost for our budget constraints. Okay, so taking the cost equation and making y the subject, meaning we need to rearrange this equation to that. So I'm going to make y the subject of the formula. I'm transposing the 1,005. So on the left hand side, it's going to end up being a negative 1,005 y equals to 1,000x minus c, dividing both sides by a negative 1,005, negative 1,005 divided by negative 1,005. These cancel. Y is equals to 1,000 divided by negative 1005, that's negative 2 over 3. Dividing gives us a positive c over 1005. There we go. There we go. Yes. Yes. Okay. So the gradient of the search line, it's this m value. It's the coefficient next to x. It's this coefficient next to x, which is m. That is m. Therefore, the gradient m is equals to negative 2 over 3. Done. Done. Going to 5.2.4, we're now going to be plotting at A. Use a scale of 1 to 2 shallots. Represent the inequalities graphically on the attached addendum 5.2.4. Okay. I'm gonna copy this. I don't need the mouse. So let's just copy that. I need a selection, not the entire thing. Okay, perhaps if I do this, there we go. Right, we are over here. Alright, so this is A, where we're gonna plot. So each block is gonna represent 2. So this is 2, 4, then 6, 8, then 10, 12, then 14, 16, then 18, 20, then 22, 24, then 26, 28, then 30. I'm gonna stop here. Then it's 2, 4, 6, 8, 10, 12, 14, 16, then 18. Okay. Okay, so using a scale of that, represent all the inequalities. So we have how many? 4. So let's start with 1 and 2. X equals 4. X equals 4. X equals 4. So I'm gonna use black again. So that is 4. And another y that is 4, like this. Another y that is 4. And done. And then for the fourth one, for the fourth inequality, x plus y less than or equals to 18. So we just take that equation, get the x-intercept as well as the y-intercept. That's a simple calculation, straightforward one. So you're gonna get a y-intercept that is 18 and an x-intercept that is 18 as well. So you connect those 2 points. And for the third one, yeah. Now for this third one, maybe let me use red for this one. Let me show you something. If you try to calculate the y-intercept for this, the y-inter for this, you let x be 0. So you're gonna have a y that is equals to 2, 0. Y is equals to 0. So you end up having a 0 and 0. And even if you try to get the x-intercept as well, y be 0, you're gonna end up having a 0 and 0. Let me show you. So going back to that equation, substituting 0, then 2x dividing by 2 dividing by 2, 0 is equals to x. Again, you land to the same point. So both the x-intercept and the y-intercept, they coincide with the 0, 0 point at the origin. So that is the point we have. Alright, that is the point. But now the question is, we now have the x-intercept and the y-intercept. Does the line goes like this? Does it go in this direction, or this direction, or that direction? That is the question. That is the question now, right? Had we had maybe 2 points, it was gonna be easier because we were gonna connect those 2 points. Now we'll have to generate an extra point or work out an extra point that we can connect it with this one at the origin. So I'm gonna take the same equation, the same constraint. Is it less than or greater than, or less than 2x, like this? So you can just choose any point. I mean, you can choose any any x value that you can substitute so that you can get y. So you want to generate a point by choosing your own x value, substituting it into the equation, then you get y. Any point, it's really up to you. So I'm gonna choose a value that is popping out to me on the screen. It's the 6. So I'm gonna say y less than or equals to 2, substituting 6. Y less than or equals to, multiply the 2, you get a 12. So 6 gives us a 12. So 6, 12 is right here. So this is the point 6 and 12. Connect, 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 connect like this. There we go. There we go. So this is the general trend of the line, y less than or equals to 2. Now for the next question, they want us to do what? They want us to do what? To indicate the feasible region on the graph, right? So we have the line, we have this line x greater or equals to 4, and another line that is y greater or equals to 4 as well, and we have the x plus y less than or equals to 18, and we have this y that is less than or equals to 2x. Now there are regions that are potential feasible regions, like this region here, region number 1, this block can be considered a feasible region. It's a potential feasible region. Number 2 is another potential. Number 3 a potential. Number 4 a potential. Number 5 a potential. Number 6 a very convincing potential. So the next step after labeling the potential regions would be to identify the feasible region by drawing an arrow as per inequality into each region. Like for instance, we're going to take this y greater or equals to 4, this line, lapha region 2, since the inequality is pointing to the right, greater than, an arrow goes in here. And then for the 6th region, another arrow goes inside because the inequality sign is pointing to the right. For that y greater or equals to 4, another arrow can be shown in the 5th region. Now for the y greater or equals to 4, in the 6th region, pointing up, another region right here pointing up. In the 1st region, another arrow can go in here, generated by that y greater or equals to 4. And then for the red line, I have an inequality sign that is pointing down. Where's my marker? Okay, right there. So I have an arrow that can go here, and in here. And then for the last one, for the last inequality, this one, since it's less than, the inequality sign is less than, so I'm pointing in the 1st region, 2nd region, 6th region, and the 5th region. So after pointing in your arrows in each region, the next step would be to identify the region with the most arrows. Take a look at number 6. Number 6 has how many? 1, 2, 3, 4 arrows inside. So that makes it as, that qualifies to be the feasible region. Then I'm going to erase the rest. I'm erasing the rest like this. Erasing the rest. Okay. Erase. And then I'm going to shade the feasible region. So I'm going to do this. It's going to look ugly now. Alright, but this is your feasible region. This is your feasible region. Then you label it feasible region. Feasible region. Okay, a feasible region. There we go. There we go. There we go. There we go. Draw a search line on the graph and calculate. Draw a feasible. Draw a search line on the graph and calculate the maximum cost for their stay. All right. So a feasible a search line, we draw the line using the gradient of that search line. So you need a y value that is 2 or a factor of 2. I mean a multiple of 2 divided by x, which is a multiple of 3. So for instance, if you take 6 as y and then you take maybe 9, so 9 is around, this is 8, 9 is around here. A 6 divided by 9, let me just confirm. Yeah, a 6 divided by 9 is what? It's 2 over 3. So you are looking for such points. You are looking to connect such points. So after connecting after connecting these multiples that when divided they give you a fraction of 2 over 3, you have your first search line. Then you can continue drawing parallel lines along, parallel line, parallel line, parallel line. But when you are doing this in a pencil, right, so that you can erase after identifying the maximum. So look, as you continue, okay, as you draw these parallel lines, the first line that's going to touch the feasible region is considered, or it's going to give us the minimum. And the last line that touches the feasible region, in this instant it's this one, it's going to give us what? The maximum. So the maximum happens along that blue highlighted search line. So I'm going to erase this part and then show the feasible region, the search line that gives a maximum. So this is a maximum, okay? This is a maximum. A maximum happens at that point, at this point, this red point right here. So what are the coordinates for this point? It's 6 and 12. Where did I get the 6 and 12? Why did I write that? Oh, okay. I remember now. It's a point that I chose to use as another point to connect that red line. Okay, so now that we have, so C, I'm gonna write here, C, draw a search line and calculate the maximum. So the maximum we calculate using that cost equation, 1000x, 1005y, 1000x, it's 6. 1005 for the y, I'm substituting 12 like this. We calculate 1006, 1005 times 12, 24,000. 1, 2, 3. 24,000. So that is the cost for that particular day. All right. Then we have 525. The last question: due to cancellation of tourists, the group on arrival consisted of 10 families who needed type B. Who needed type B? 10 families who needed type B of chalets, and 3 couples who required type A chalets. Will the tour leader be able to meet the requirements of all the tourists in their booked chalets? Give a reason for your answer. Let's try something out. I was gonna look at the I was gonna try to plot the point and see if it's within the feasible region or outside the feasible region. But let's just check. Let's calculate the cost of that arrangement. So it's 1,000. How many shallots for the type B? For the type B, it's 10. So for the type A, it's 3. So it means that in the cost equation, where there's X, I'm substituting 3. 1,005. For the Y, I'm going to substitute 10. And then I'm going to calculate. If the answer we get exceeds that 24,000 or is more than that 24,000, we won't be able to make arrangements for such. So 1,000 times 3 plus 1,005 times 10. Interesting. 18,000. 18,000. But wait. It's something I wanted to try. So type A, it's 3. 1, 2, 4, then 3 is around here. 3 is around here. And then we have 10. It's outside the feasible region. Now, how do I reconcile this? Okay, so since the point lies outside let me go back to black. Okay, yeah, perfect. So this is the point. If we try to plot these, lies outside, okay, it lies outside the feasible region. So it means that anything within this feasible region can actually satisfy whatever thingy, whatever arrangement we have. Not this thing. No, we don't look at the cost. I just wanted to observe something through that calculation, but it's not gonna work out. There's no reconciliation, nothing to reconciliate. But if you wanna address such questions, plot, and check or see if the point lies within or outside the feasible region. Thanks for tuning in. Thanks for watching. I hope you enjoyed the recording. I hope you got something out of this discussion. Check out the description box. If you happen to be watching question 5, there's a whole recording for this question paper. I left the link for the full recording in the description box. Check it out. And yeah, leave a like. The question, let's talk in the comment section. You're new to the channel, please consider subscribing. I'll catch you on the next one. It's been a rough discussion. All the hours that I've spent talking, I'm hungry now. Peace.